You're listening to the Seen and Solved podcast brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to this edition of Seen and Solved by Hubbard-Hall. I'm your host, Tim Pennington, and today I'm joined by cleaning expert Mike Valenti, Hubbard-Hall's Director of Technology. Mike, thanks for joining us today.
Hey, thank you.
So I want to talk about, I know you're out in the field a lot, you're in shops, you're in facilities, you're in manufacturing operations. Tell us about, I want to hear something that you've kind of run across that you're working with a manufacturer on solving a problem that they would have related to cleaning. So which one comes to mind?
Yes, I'm going to talk about one that we currently have in progress that I guess would be kind of one of the more novel things we're working on to give people a kind of an idea of how complicated some of these things can be, and kind of it's a kind of a paradigm shifting problem for not only customer but for us. So we can talk about. So I'm going to talk about a particular application, and it's aluminum packaging. And why it's important is there's a trend in the market. You'll see if you go in a store, you're going to see more and more packaging moving from plastic to aluminum. And the reason for that is the whole issue of people bringing up that plastics are polluting the ocean, microplastics. So there's a major push to move back. And plastics, you know, when you recycle a Coke bottle or a water bottle, there's a limited number of times you can recycle plastic and use it back into a package before it degrades. Aluminum is almost endlessly recyclable. So this type of package, when it's thrown away, they can recycle over and over and over and over and use the metal back in the same process.
Interesting.
Yeah. So there's a big push. So there's companies that specialize in making these, and these are highly engineered packages. There's a lot of technology that goes into this in the you know, the actual graphics, the liners on the inside, everything. But specifically, the key to making this is the actual formation of the parts and getting the parts clean. So these packages are made through a process called impact extrusion. And simply what that is taking something that I can probably, the closest analogy is a hockey puck. And it goes through a high-speed process and it's turned into one of these cans. So this can, this nice aluminum can is what eventually becomes one of these packages. And there are many, many steps between this part and getting to this end result. So there's a couple of really critical things about these parts. Number one is the cleanliness of the can and the adhesion properties of the aluminum. And so why is that important? So when you make an aluminum package, every package, whether it's got shaving cream, suntan oil, Coca-Cola, whatever's in there, there's a specialized lining depending on that product on the inside of this can. And that lining protects the product and it protects the package. And making sure that lining is adhered properly is critical, okay? So the cleanliness of these cans on the inside and outside where all the graphics are is critical. The other thing is there's also not just cleaning, but there's surface treatment going on at the same time of these cans where you actually put a mild micro etch on the surface. And this all has to be done at one time. The lubricant has to be cleaned and we have to put a micro etch on the surface, and the micro etch is so you get adhesion of that liner and the graphics on the top, okay? And just to give you an idea of scale, like one facility that makes these type of cans will make, you know, over 1 million of these in a 24-hour period. So they're banging these things out really fast.
Literally, yeah, just pounding them, right? Just right.
So the typical way that these types of cans are cleaned, so when they come out of the extrusion process, they are literally, they're not black, but they're very, very dark and discolored because the lubricant they use is a waxy, fatty stearate lube. And that lube, it's a very harsh process and it discolors and it actually reacts into the metal. Okay. So if you were to take a can that comes off the extrusion press and hold it with your hand, it would feel like somebody coated it with beeswax or something. It's very, very sticky, right?
Is it almost embedded into the metal?
Yeah, it gets embedded. The aluminum actually tears during what actually happens to the aluminum when it goes into the extruding press is it flows. So the metal actually flows. And then it goes to a second process called ironing that then trims and puts a little dimple in here and so it's a two-step process. So yeah, the lube gets pushed down into the micro tears in the surface, and it actually will react with the metal in some cases. So really difficult to remove. So the standard process to do this is a heavy duty caustic inhibited alkaline spray cleaner. Okay. And it does a pretty good job of removing this lube and putting this etch on the surface. But what happens in that process is that lube during that cleaning process is converted into a soap. Okay. So imagine it's the old, lard and lye kind of reaction where you've got something that's a fatty acid reacting with caustic, and you make a soap, and that's part of the reason it comes off. Okay, and then the chemistry puts the etch on the surface. So you're also putting a lot of aluminum in the bath at the same time. Okay, well, what happens to this sticky, gummy stearate soap and all the metal is they start to react with each other, and when they do, they start to form scales. And the scales start to deposit on the walls of the spray washer, in the nozzles, in the pipes, on the heating elements. And the more these tanks run, the harder this scale gets until you get to a point where it also almost turns into like rock. So what happens is it starts to plug the spray lines, the nozzles. It starts to get on the heating coils and starts to coat those. It reduces the ability of the heating coils. It can cause the heating coils to fail. So what these manufacturers end up doing, they may have 10 or more of these lines running at any one time, is they have to shut these lines down on a frequent basis, empty all the chemistry out, and do a heavy descale process. Okay. And part of that process is taking fairly hazardous materials, pumping them into the system, heating the washers up as hot as they get, and circulating this to try to dissolve and break up all this heavy scale material. So you say, well, that's not a problem. They just need to do that. Well, here's the problem. Number one is it creates a significant amount of downtime, because now you got to shut this line down, and you may have to spend an entire day doing nothing but descaling this line. Okay. So you've lost production on that line for an entire day,
which you'll never get back.
Yeah. Not to mention the wear and tear on things like I talk about. The heating coils fail, pumps, this material starts to build up. It can affect the meters, things they have in the tank to detect level. There's just a lot of issues with how it affects the equipment and the wear and tear on the equipment. Also, these materials, they don't completely dissolve into the bath. They turn into like a gummy, just gummy substance. They have to constantly, remove this stuff. So it becomes a real problem. So they approached us, and said, hey, is there any better cleaner that we could use to do this process and try to eliminate all this scale and problems? So in the beverage can industry, if you go to a major like Crown Cork and Seal or one of those guys that are making Pepsi, they're doing acid cleaning on those cans typically. So we said, yes, one of the ways we can eliminate this is to do acid cleaning. And so you say, well, that's just easy. We're just going to throw an acid cleaner in there and away we go. Well, I wish it were that simple.
Right. I'm hearing a but come up.
Yeah, there's a but. So,
right.
So the issue, one of the issues is, and people kind of laugh when I tell them this, but these systems foam like crazy. Okay.
Mm.
And so one of the things they have to do, because they have to run RO water in to get the water quality right, RO water causes more foaming. So this alkaline system they have running today, they have to actually throw calcium chloride salts in the bath to keep the things from foaming, which creates more scale,
Really?
more problems.
Right.
So,
Mm-hmm.
so we said, hey, we'll go an acid cleaner. But when you make a major change at someone that does this type of packaging and makes this many parts at one time, having them make that change, we have to put this, like, we can't change the appearance, we can't change the amount of etch, right? Because anything we change is going to affect, these lines are as long as football fields, some of them, right? Maybe not quite that long, but they're pretty long. And so we can't change the physical properties of the appearance of these cans.
It'll affect something else down the line, right?
A whole lot like these graphics. So here's the interesting thing: if you make them too shiny, then this comes out too shiny. If you make them too matte, then this doesn't look right. So it's a great example of how we've had to work to formulate and get a product that meets all their requirements, and at the same time, when we run testing there, we're not allowed to scrap parts. So we have to make good parts to get through the testing, right? But this is a great example of doing something innovative in an industry that has been doing the same thing the same way for forever.
Yeah. So what parts did you all use? Was it something with Hubbard-Hall that you guys could give to them that they could solve that issue then, or?
Yeah. So we've actually got candidates now in testing that we've started to test. They're acid-based cleaners, but the other thing is they put a lot of restrictions on us. Can't have certain chemicals in that. Yeah. They've put a lot of things we can't use. So the standard things that we would normally use as acids to do this, they told us were off the table. So we've gone into our bag of acid cleaners that we have done some other novel solutions for and are using those chemistries, and we're pretty close at this point to getting them. Yeah, but this is a great example. This is a major change for someone like this, and it's a risk to them because you really don't know if you've got the right product in until they're running 24 hours a day, 7 days a week, and they're never making bad parts. The amount of testing we have to do on site just when we run a trial is pretty amazing. We do have a partner technology that we partner with where we can actually measure the amount of etch on the surface of these cans on the outside and inside. And so we now know when we go, hey, this is the numbers we have to hit. And if we hit those numbers, we're going to make good parts.
But this could be very, very, very good for them in the fact that, they're not having to shut down lines to do maintenance, cleaning, things like that, which is, again, it's not like they shift it to another line. They just don't use that, and they're not getting any production out of it at all, and they'll never get it back.
Right. So our goal is to stop the downtime. They run an acid cleaner. They don't have to worry about scale. The acids keep the scale, and the acid cleaners also hold these lubes better. They treat the lubes better. They don't create as much contamination. The way the lubes are held in the tank are different. So it does solve a lot of problems for them, but it's probably one of the biggest, more difficult opportunities that we've had to work toward to get results. But it's great. Yeah. To me, it's a really good example of, you can't just go in sometimes and throw product in. You have to really, really do a lot of work, this is a big problem for them. They're really willing to do the work, and they're patient with getting the testing done because they see it as a big benefit.
Right. Well, we'll have to talk soon. Like I said, when all this gets finalized and you run the test parts and you get the final thumbs up, we have to come back and revisit this and kind of get into more detail exactly.
Yeah.
Maybe that's going to be a new product that you're going to be released, because like I said, a lot of people are doing that as you.
Would be a brand new product for us. Is actually be a new market. You know, we kind of have a focus in the aluminum market. We have a lot of unique products. We've had some really unique successes in cleaning aluminum. And so that's a kind of a focus area for us, because like I said, you're going to see more and more shift of things, packaging. You know, it's already happened in the automotive industry. My truck I drive, my Ford truck, the whole body's aluminum.
Right. Well, lightweighting. Yeah.
Yeah. You're going to see a lot more people, a lot of the job shops that we have dealt with are doing more and more aluminum and less like black oxide and things like that. They see kind of the shift in parts that are being, so it's a focus area for us. So
interesting, very interesting on that. Yeah, especially as the interesting. And like I said, we'll check back with you and when everything's up and give us more detail. Thanks for sharing that, Mike. Appreciate it.
All right, appreciate it.
The Scene in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Allcast.